Okay, let's do the widths and distances a little more clearly and correctly here. And think about our solar system, and let me say that in studying our solar system, we're studying the only region we can explore with our spacecraft within a reasonable amount of time. Stars take tens of thousands, hundreds of thousands of years to get to current technology, and that's the closest one. So this is it. So, but by studying our worlds, we can think about the worlds that are being detected around other stars as well. And if you want to know about our planets and moons in our solar system, where there might be life or what's going on inside them, comparing them to Earth's 6 layers, then you need to know about their size and their distances. And knowing a planet and a moon, planets and moon sizes, we can talk about the volume, and ultimately it's the volume that matters, but I think it's easier to draw width this way, width that way. So there's a nice also memory aid here. And so I just played with the numbers, was looking for some patterns that I could share with people, because this is so important to know the widths and the distances, the sizes, if you will, really the volumes, and the distances. Why? Because if you knowing planet and moon sizes or width, we're going to compare everything with Earth. It's reasonable to do that. How many diameters of Earth? How many widths of Earth? I use capital D for diameter. You can think width, and I use E for Earth. You could use a UR here symbol if you wanted to. Tells us about the interior warmth. We studied Earth, we studied Moon, we saw that contrast between Earth and then Moon, quite a bit smaller, and we talked about that before. So if we look at Mercury, Venus, Mars, other moons, knowing that width will give us a good clue about its interior warmth. Is it still active? Has it got volcanoes? Has it got tectonics? Is it releasing gas for an atmosphere? What's going on? Or is it dead? Is it pretty much cooled down inside for the most part, not really moving around much, not much volcanism, maybe no atmosphere, maybe no magnetosphere? These are the things that this can tell us. Also, knowing the distances. How many AU, or fractions of an AU, or multiples of an AU? 2 things. Knowing the distances from Sun, how far from Sun, tells us about the surface temperature, right? Maybe we want to know if there's going to be liquid water, whatever. It tells us a lot about the surface temperature. Obviously, if you're closer to the Sun, you're going to be a lot hotter. And if you're farther away, you're going to start getting colder and colder and colder, and very cold. Also, so distances from Sun, but also distances from Earth, right? Tells us about space travel. Now, whether or not there's people on the spacecraft, we can send robotic probes out there, and that'll talk to us about how long it takes to get out to those places. So knowing these sizes or widths and these distances will give you a tremendous sense of our solar system. And in fact, in the next chapter, we're going to be talking about characteristics of each of these worlds fairly quickly, because we'll know so much about them. Memory aids are key. So let's start in, and we're going to start with, of course, those 4 inner planets. The first 4 planets. And you know what they are because you know the memory aid, right? My very excellent mother actually just sent us 9 pizzas and Cokes. Okay, so in the book. So you know what they are, but I drew them kind of like that, and just a simple drawing. In the book, I've got lots of exercises to help you remember this. But here's another exercise. So here, I've set it up to look at the 4 inner or terrestrial planets. They're Earth-like in that they're metal in the middle and rock around it. So that's pretty much the extent of it. I mean, there's, that's why they're kind of Earth-like, but it doesn't mean they're just like Earth. Terrestrial, Earth-like planets. And you get two bonus today only. Simple fractions is the memory aid. It's amazing. These aren't exact numbers. You can look those up, but you'll never remember them unless you use them. And if you're doing science, you use them. But to get a sense, we can say, how wide are they compared with Earth? How many Earths wide, or fractions of Earth, if they're smaller? And how far, in this one, we're going to talk about how far from Sun are they, because that's the pattern that I came up with. How many AU from Sun are they? Okay? Now, simple fractions. So all you have to remember is the pattern of simple fractions. You got to work it a little bit, so work those exercises in the book, kind of drill it until you've got it down. And we'll go over that right now. The diameter of what is equal to 1 diameter width of Earth? The diameter of what planet is about 1/1, the diameter of Earth. I wrote it like that for the pattern. 1/2, 1/3, 1/4, 1/5. That's a nice pattern, right? It's a nice pattern with simple fractions. And then we'll look at the simple fractions over here. The answers are simple fractions with one exception. So how could you possibly know this? Let's take a look. Look it up on the internet. There's all kinds of pictures around. There's these nice graphics, somebody generated over here. Let's take a look over here. Coming in. All right. So as I may have mentioned, Venus doesn't look like that. This is colorized. This would be if you took an image getting the warmth of Venus with, say, infrared or something. This Mercury is much more gray, with maybe a touch of brown, but most of them are gray. Pluto, they didn't have a good image of Pluto until 2015 when we flew by there with New Horizons. Okay, so, take it for it. But the sizes here, I mean, how would you know the sizes? You just look and they're just dots in the sky. So this will be your clue. Remember that with that image. Which one of these has the diameter of Earth is equal to? And which one of these is the width equal to 1 diameter of Earth? Which one of these is the width approximately 1/1 diameters of Earth? Which is about 1/2 diameters of Earth? Which is about 1/3? What about 1/4? You know that one. What about 1/5? Okay, that's what we're going to look. You see that? You can pause. You can go back to it. Let's do it. Don't just memorize it. See it. See it. And there we go. That's what we're going to fill out. But let's see this in the physical. Okay. Let's look at it physically. In other words, three-dimensionally. So three-dimensionally, I've got this. 1 diameter of Earth. This way, top to bottom, side to side, front to back. Okay. So some world is about the same size, a little smaller. Some world is half as wide each way, 1/2 the diameter of Earth. Some world is 1/3. And if you shrink it by 3 each way, it goes like that. You know this one, 4 across and 5 across. This is interesting. There's a lot you can learn from just this. A lot you'll know just from that pattern. Make sure you've got a good picture, image of that. Okay, so you can see it. Coming up. All right, and you might try filling that out. You might pause and fill it, then you really remember. When you struggle with it a bit and you get it, that's when we connect the brains, literally grow the connections in our brains. So, you know who is 1 diameter of Earth? Well, it's Earth. Okay, and there's only one with E, so I can put that E. You know that's Earth. Earth. But which world is about 1/1? Diameter of Earth, you saw the picture, you can rewind. Get it? V, there's only one planet with a V that starts with V, so you know that's Venus. It's a little smaller, 0.9 is closer if you want to be picky, but this fits our pattern. Which world was 1/2 as wide each way? We mentioned this in talking about the origin of the moon, by the way. Now, I can't use M here because there's too many M's. So, Mars. Right? So that's interesting. Mars is 1/2 as wide. That's going to tell us so much. And there's some cool patterns. We can really use this. So you go round and round and round, but you got to do repetition. Which world was 1/3 as wide? Another M. Mercury. Mercury. 1/3 as wide. So Earth, Venus, Mars, Mercury. 4 across, who? That's right. Moon. That's your bonus. I know it's not a planet. And who is 1/5 as wide about? You know who that is? Pluto. Okay, so that's interesting. Here's Earth, Moon. Pluto is even smaller than Moon. Maybe that's one reason for kicking it out. We'll talk about that. Okay, so you've got that here. Now, how far away? If I gave you the distances, could you match them? Of course you could. You already know enough. You just have to get in the habit of using your memory aids. And you got to use repetition on these guys, okay? So let's do it this way. Okay, let's do it like that. There they are. Pause and name them. Earth, Venus, Mars. Who's next? Mercury, Moon, Pluto. But they're not in that order. That's not the order of the planets. How do you know the order? Oh yeah, the order. The order was my very what? Yeah, you know that. So let's put them in. I'm going to put Sun here. Now you know Sun is enormous compared to these folks, but I'm going to put Sun right there. That's going to be my Sun. Not worrying about this. Not going to worry about that size and making it perfect. Okay, and so let me put Earth here. How far away is Earth from Sun? 1 AU. But I'm going to think of that as 3/3. Check this out. What's the order? Just forget about the distances. What's the order? Oh, my stands for Mercury, which ends in a Y. My ends in a Y. Mercury. That was this one. 1/3. Now you're going to see a nice pattern here. 1/3. Very. Venus. Excellent. Mother. Mars. Right? I could do this a couple of ways. My very excellent mother. But what's the separation? What's the pattern? What are the numbers? Well, it's pretty nice. It's pretty nice. One of these, because now I kind of gave you the answer, I could have done it another way. I could have just put this up. The simple fractions here are not the same as those over here. I've got a 1/3, I've got a 2/3, I've got a 3/3, I've got a 3/3, and these are approximate, right? They're pretty good if you look it up, but you know, it's just a memory aid. And then over here would be so nice to be 4/3, and you'd kind of be right. But there's a couple of reasons that I don't go with 4/3. 1 1/2. 4/3 is just not quite good enough, and there's a bonus by going 1 1/2. So you pause and connect them. Pause and connect. And you're back. I hope you paused. Do the grind, do the work. You don't get anything. It's the people that grind it out that do the best, okay? You can get the most. So where are we? Oh, look at that's in the order from sun. Closest to sun, my, very, excellent. Wait, what's that? My, let me just write that. My, very, excellent. Is Mars right at the same distance from sun? No. Who's the same distance from sun as Earth, effectively? Yeah, you know what that is. So, mother, and you can figure out who the other one is. So, how do we connect those? I can go over here and play a game. Oh, how far is, or let me do it this way, it doesn't matter. 1/3 of an AU, Mercury. Mercury is 1/3 of it. Look how nice that is, come on. That's just crazy. But a DE is tiny, right? DE is teeny tiny. Remember, I'll say it over and over, if you shrunk sun down to be the size of a softball and then you took a grain of sand where you can get 100 grains of sand, 109, across, the grain of sand would be Earth. Cut that grain of sand in half and then half again, that'd be the size of moon. So you got 1 grain of sand, then a teeny grain of sand, 10 long steps for me, and if you're shorter, maybe 15 or 20 steps out, would be 1 AU. So an AU would be way out there, and a DE would be a little grain of sand. DE is very tiny little bit compared to an AU. Okay, so keep that in mind. Don't confuse those. Think about it. You got to think about it enough, or else they'll be confused. That's what we do. We confuse things. Confuse with fusion together. Okay. So that just happens. It's not exact, but it's a pretty good thing. Mercury. And there's some other things that are thirds. We'll get to that in chapter 8. So 1/3 of a DE, 1/3 of an AU from sun. It's the closest to sun, right? Then who's the next closest? Oh, Venus. My very. So now that's not as lucky there. Fine. Just the way it is, right? Venus is almost as wide as Earth. Now who's 3/3? Well, 3/3 equals 1. So of course Earth is. But who else is? Moon, of course, is effectively 1 AU from sun. Leaving who? Leaving good old Mars, right? You do this in black. And that's why it's so nice. Instead of going 4/3, I go 1, so it's past Earth, 1, by another half of an AU. And I've got the 1/2 and 1 1/2. That's a pretty nice combination in my book. And then way, 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 way out there, good old Pluto. Pluto is, on average, about 40 AU away. or 30 to 50, got the 5 and the 50 if you want, whatever it takes, is going to be here. Now I know the widths and distances. And so I can play with this in another couple of ways too. Once again, let's do this. And I can space it over here. So wherever, I got that, wherever Earth is where Moon, 1/4 as wide, is. Right? And then wherever Sun is, between Earth and Sun, just barely get it in there. Make sure that I'm good here. Hold on a second. All right. Make sure I don't lose this battery. Sorry, guys. Hold on, sorry. Crash bang. All right. Choice of self video. All right. That's 1 AU from that one edge over here to that edge here. And I simply divide it up evenly. 1/3 of the way, 2/3, 3/3, 3/3, and then 1 plus another half out to Mars. Now I can draw that more simply. Let's see if I can get that over here. 1 plus another half out to Mars right there. Let's draw that and finish this guy up. So we can really know this, play it round and round. You will have learned so much. So I can draw the distances very easily, actually, if I do this. In fact, I kind of did. So I could draw it like this, and I could say, okay, if Earth is here, now let's watch this. I'm going to make Earth blue. I know Earth's a little bigger, so I'm just going to E. And then I just evenly space them. I just simply evenly space them. So I've got 1/3 of an AU, 1/3 of an AU to Mercury. Venus would be 2/3 of an AU. Earth and Moon are 3/3 of an AU equals 1 AU. And then finally, out to Mars, I've got 1.5 AU. So how I've drawn that, half of that would be about like that. Take that over here. See, it should be about more like this. Good. Go like that. Fine. So the spacing a little bit farther out to Mars than to Venus. Venus, when you line it up like that, they aren't always lined up. Venus is a little bit closer than Mars. So why not go to Venus? You will see. Now, how do I draw the sizes? Now, I have that in the coach, and you can see those sizes. So what I often like to do are do 2 circles. Now, both of these are Earth. So that's Earth, and that's Earth. I'm just trying to show my friend how big these things are. So one thing you can start with is the biggest one, and that's Venus, and that's just inside. So I'll draw it just inside. I know Venus is a little bit smaller. So this is going to be Venus. And then just because I'm going to cut it up a certain way, you'll see why in a second. I cut this up. I'm going to cut it up into thirds. Divide that by 1/3. Roughly 1/3, 2/3, 3. So, and then make a circle, not an egg, a circle. And so across here and here, that's going to be the diameter of 1/3 DE. And you know who that is? Good old Mercury. So I can show Venus and Mercury easily there, but then it gets a little cluttered. So I'm going to take Earth and I'm going to cut it in half. And I know if I cut it in half, I'm going to get one world that is 1/2 the diameter of Earth, and you know which one that is, Mars. I'm not even going to write it. And then if I cut that half in half, you know that that's now a quarter dE, and you know what that is. That's moon. So I will ask you two quick questions, and we'll move on to the outer planets next. And that is, and I won't give you the answer. You should be able to figure out. Which two would you expect to be the warmest inside? What tells you the warmth? And which two would you expect to be the warmest on the surface? What tells you about that? And then you are good to go. You know a ton. Let's do the outer four, shall we?